Okay, I downloaded your spreadsheet and loaded it into Excel. I'm looking right now at the data from your run number 9. I'm assuming that this is one of the solute added to the solvent, so these are one of the solution runs. Now, currently there is no graph, and what I'm going to do first is just do a simple graph looking at your raw data, so that way we can go ahead and do the trend lines. So first, I'm hoping that you are familiar with making graphs. I'm going to go ahead and highlight your information in the time and the temperature columns. And in the charts area, I'm going to select scatter. Now you can either do the mark scatter, the smooth mark scatter, or the smooth line scatter. It doesn't really matter, but for this run, I'm going to go ahead and do the smooth line scatter. And the initial chart is created for us here. I'm going to make it a little bit bigger so we can both see it. Now, as you can see, there isn't a clearly defined plateau anywhere in this region where we can say the phase change has occurred and we're all finished freezing our cyclohexane solution. So we're going to have to extrapolate and figure out where this initial descent would continue on and where this tail, if for lack of a better term, goes out. Now, in order to do that, we're going to have to make a trend line that's descending along this initial slope and a trend line along the data coming out here on the tail end. The problem is that you can't do two different trend lines on the same set of data. So we're going to have to basically break this up into 3 different sections. 1 is going to be the initial descent. 2 is this inner region where the initial curve starts, and then finally the tail end where the data kind of slopes off into the end of the run. So first I'm going to trace along looking at my graph, and I'm thinking that I want to make sure that when I'm looking at this general area on this side that I know where the line ends and the curve starts. So it looks to me about in this region is where the straight line stops and we start getting the initial curve. So if I hover over the curve right here, this is series point 1, and it is at 30 for the time and 13 for the temperature. So that would be right over in this area. So if we look down here again, yep, 30, 13. So the first set of data here, I'm going to go ahead and highlight it. From 0 to 30 seconds, I'm going to color code it. In this case, I'm just going to make it yellow. There's no rhyme or reason for the color scheme here. I just want to set those data points aside. And then after the curve region in here, I'm thinking about here, about 285 seconds, heading on out is when it gets to be a more linear fashion. So if I highlight that section, 285 out to your 675 total, I'm going to highlight that in another color. In this case, I'll make it light green. So those are my 3 sections. The initial descent, which is very linear, right here, and then we have our curved region where the phase change and the freezing was occurring, and then we have the tail end in green out this way, which is showing us a linear progression cooling down even further. But what we need to do is we need to replot the data in each of these sections. So what I'm going to do that is right-click on the plot area. As you can see here, there's the little cross. When I right-click, we have an options menu that comes open, and we want to select data. And currently, you have one series of data in the plot, which is the original curve. But again, we want to break that up into 3 different sections. So at first, we're going to go ahead and remove that set. And if you look, I'm going to move this window. The graph that we had is now gone because the data set has been removed. So I need to first add my next set of data. So I'm going to click Add. And I'm going to call this Curve 1, or the first part of the original cooling curve. The X values, of course, need to be our time values. So I'm going to click this little icon right here at the end of the line. And now it's waiting for me to enter my X values. Now my X values are going to be these first 3 right here. 0, 15, and 30. And as you can see, A2 through A4 has been selected. if I hit return, it has now placed those values into the x values. Now I need to insert my y values, so I'll get rid of this equals 1. Click the icon at the end of the row, select my y values, the top 3, hit return, and as you can see, it has now plotted those 3 values in a fairly straight line. Of course, it looks kind of disproportionate because the scale is only for these 3 points. Next, we have to add in our next set of data. I'm going to call this, ignore that, I started typing right here. I'm going to call this okay, let's try this again. Curve number 2. The x values are going to be the uncolored section here, 45 seconds out to 270 seconds. Hit return. My y values are going to be the corresponding values in the table. So if we click the icon and highlight, hit return, and as you can see, move this out of the way, now in blue we have the original set, and then in red we have this new set that we just added. But we have not finished because we have to add the last set of data. We have to add one more curve. Curve number 3. Selecting my x values from 285 seconds out to 675, hit return. And then I have to select my y values, which are, again, the 675 up to the 285. Okay? If I show you, all 3 segments are now on the graph. Okay? So, we are now going to click OK to return back to the regular spreadsheet. And there's our graph. Now, as I said before at the beginning, we have to put trend lines in. So, the first one, I'm going to click on the first set of data, which is our blue series, which is the original curve. And you notice it is now selected. Now, once it's selected, we will right-click on that line. And when the menu pops open, we are going to select Add Trend Line. Now, as you can see, there's variations you can use, a linear trend line, logarithmic, and other mathematical functions. We want to leave it on linear. On the options section, now, if we go ahead and leave it, as you notice, there's already a trend line displayed on the graph, but it's only going as far as the original data set. We want the trend line to extrapolate or extend on, continuing down. So we want it to go forward, I'll say 50 periods. Now this is an arbitrary number, and as you can see when I add the number, it's extended the graph. So that's all right. We also want to display the equation on the chart for this trend line we just created. As you can see, it's down here in the lower left-hand corner. And then we'll click OK. Okay. Now, so this is what the curve would have looked like if it had continued to descend, going straight on down. But we need to see where it will intersect with the curve coming off of the green graph. So I click it to highlight it, right-click, and I say Add Trend Line again. Same procedure. It's already on a linear fit, the options. I want to display the equation, but I also want to extend the trend line all the way back so that it intersects with the first one. So I'm going to go ahead and say I want to go backward 50. Measurement must be between 0 and 5. Well, I beg to differ. See, it's extending out this direction, but I want it to go out 50. This is very odd. Let's try 5. There we go. I'm going to go ahead and delete the trend line. Let's see. I'm going to delete the trend line. I'm going to add it back in to see what would happen. So let's add our trend line back in. And we're on a linear fit. Options. Let's see what happens. And display our equation. Not sure why it's not fully extending, but basically what we're trying to see is where this trend line, if it extends even further, where it's going to intersect over here. Now, since you have the equation for both this line and for the other trend line, you can basically solve one of the equations for x and then plug that x value back into the equation and solve for y. When you solve for y, you're solving for the temperature, because that's the y coordinate, at which both this trend line and this trend line will equal to one another. So once you solve the system of equations, that'll tell you what the actual freezing point was for this solution after adding the solute, which, if I eyeball it going back over here, it's probably going to be around, thinking around 5, maybe 5.5 degrees. But you can also, if you so desire, instead of doing it in Excel, you can print out your graph and use a ruler to make an extrapolation of the original descent, an extrapolation of the tailing end of the graph, and see where they intersect. Using the Excel method with the two equations is more exact, but if for whatever reason you don't have time to go ahead and do the calculations, you can do it by hand. All right. Now, that should be everything I hope you would need to go ahead and make your graphs and do your analyzing of your data. If you have any questions, go ahead and send me another message in Canvas. I'll probably be checking later on this evening. If that helps, that's great. If you do have any other questions and you feel you just need to ask me in person, you can ask me tomorrow in class if necessary. So, hope this helps, and see you tomorrow.